Hello friends, welcome to Code Sutra. In this video, we will be solving LeetCode problem number 1802, maximum value at a given index in a bounded array. In this problem, we are given a value of n that will be equal to the size of the array. For example, here we are given n is equal to 6. So the size of the array will be 6. Then we are given a maximum sum. That is, the sum of this array cannot exceed 10. So if we take this example, what is the sum of this array? It is equal to 10. So it is not exceeding the given value. And we are also given an index. In this case, the index is equal to 1. At this index, you have to form the maximum value. For example, this is the maximum value that we can put here. And there is a given constraint. What is that? The elements difference cannot be greater than 1. That is, the adjacent element difference cannot be greater than 1. For example, here it is 3. Can we put 5 here? No. This won't be a valid sequence. Similarly, this is a 3 and will be a 1. Is this a valid array? No, this is not valid. So the difference between any two consecutive elements can only be 1, and we have to make this element as the maximum element. So let's take another example. Can we form this array 3, 4, 3, 2, 1 and 1? No. Why? Because the sum will be exceeding more than 10. So this array is invalid. So let's take one more example. Here it will be 2, 2, 2, 1, 1 and 1. Yes, this is a valid array. Why? The sum is lesser than 10. But the point is, this value has to be maximized. That is, in this case, we can take this value up to 3. So 3 will be our answer. So we have to return what is the maximum value, 3 in this case. So let's look at the very first approach, that will be brute force approach. We'll take the same value. The first thing that is given here is all the elements have to be greater than 0. That is, all the elements, let's make this as 1. There are 6 elements. All the elements will be equal to 1. Now, what is the idea? The idea is we have to increase the value at 1. How can we increase it? We will just increase it 1, 2, 1, 1, 1, 1. What will be the sum in this case? The sum will be equal to 7. It is still lesser than 10. So now let us try to increase it to 3. Can we increase it to 3? No, right? So what is the idea? We have to first increase the adjacent elements one by one. So in this case, the sum will increase to 8. Similarly, in the next case, the sum will increase to 9. And in the next case again, the sum will increase to 10. And in this scenario, we can just stop it. But definitely, this will take a very huge time complexity. But the basic idea what we are trying to do is, we are trying to form a peak element here. One of the quick observation that we have to form in this is, these elements form the peak element. And any element on the left side and on the right side will both keep on decreasing. This is one of the quick observations that we have to draw. Let me give you a different example and let us approach at the binary search. For example, we will do the same thing 1, 1, 1, 1. So here we have to put the maximum element, right? So let's assume the maximum element value will be 5, for example. 1, 1, 1, 5, 1, 1. So this is not definitely a valid, right? So let's make it valid. How can we make valid? 5, 4, 3, 2, then 4 and 3. But is this valid? No, right? This is not a valid thing. So the idea is, we will keep a given range for this. What will be the range? The range will start from 1 and the range will be equal to maximum sum. So 1 to 10, what we can do is, say for example, the mid equals 5. So if it is not possible with 5 itself, can we make this value as 6 or can we make this value as 7? No, right? So if 5 is only not possible, we can eliminate all the other values. That is 7, 8, 9 and 10. So first thing that we did is, we kept a range that is between 1 and 10. So once we identify that it is not possible with 5, what we did was, we eliminate all the other choices. Similarly, say it is possible with 3. It is possible with 3, right? So then it is meaningless to check 2 and 1. Why? Because it is possible with 3. Why do we want to check for 2 and 1? So that is the core idea of binary search. What we are doing is, we are finding an element. We are finding the peak value. Then we try to form an array such that the sum is minimum. And if this sum is lesser than this maximum, yes, the array will be valid and this peak element is also valid. Let me explain the possible function once again. That is if this is valid or not. Let's take this example and we wanted to make this element 1 and 1. So let's make this element as 4. This will be 4 and this will be 1 and 1. So what is the idea here? 1, 2, 3, 4, then 3 and 2. If you look here, this is the minimum sum. Can we reduce the sum any further? No, this is the minimum possible sum that you can form with this peak element. So if you look here very carefully, this forms an arithmetic progression on both the sides. What is an arithmetic progression? This is increasing from this side and this is decreasing from this side, and this forms the peak element. There is one more scenario also. Say there are 8 elements, 1, 1, 1, then it will increase to 3, 4, 3, 2. So this is also one possible scenario. That is, there will be ones previously, but the arithmetic progression will start at some point and will end at the peak. Then again it will form an arithmetic progression with the difference as -1. So that is the core idea, and we will add both this sum, and if the sum of these both is lesser than the maximum sum given, yes, this particular value, that is 4, will be valid. That is the maximum number will be valid. So without further ado, let's dive into the code. What are we doing here? First, we are writing the isPossible function. We are taking the left value, for example here, right? So why are we picking this left value? Why? Because the 1 can start from anywhere. So what are we doing here? The left value will be equal to peak minus index and or 0. Why? Because it can go lesser than 0. In this first scenario we saw, right? That is, it can start from here also, 2, 3. So the thing is, it need not start from 1, it can start from any other. So we are trying to find what is the left value, and here we are also finding the sum or the sum of all the numbers on the left. So what is the formula that we are using here? It is just equal to n by 2 into a1 plus an. What is a1? a1 is equal to the first element of the arithmetic progression, and an will be equal to the last number of the arithmetic progression. And what is n? N is equal to number of element. So we are first finding the left sum, then we are going to find the right sum, whatever will be on the right side of the array. So then if this sum is lesser than the max sum, yeah, we return that this particular element will be true. So why are we subtracting? Because this element will be added twice, right? So we are subtracting the peak from that. Then what is the main function actually? The main function is, we have defined the range here. The range is from 0 to the max sum, and for every value, just like we did 1 to 10, we are finding the mid value, say 5 in this case. We'll check if it is possible for 5 or not. If it is not possible, straight away eliminate 5 to 10. All these values are eliminated. That is, the right will change from mid to 1. Similarly, if 3 is possible, we will eliminate 1 and 2. What are we doing here? We are just changing left equals to mid. Finally, we will return the final value, that is equal to left plus 1. Thank you for watching the video. Please do like, share and subscribe.